Jajaha, why like that to this teachings again. I'm still Ching Ben, and I know students in Kenya doing those going to do exams. Also, that you are on holiday, but there's no holiday for you. You must read. Use this time to now go through my teachings and your teachers' assignments, and every time it will help you a lot in your exams. Now, I've tackled electrochemistry. I've also tackled respiration in biology. Now, this time today, I want to talk about something called organic chemistry 1. We have organic chemistry 1 and 2 in form 4. 1 is in form 3. We'll combine them so that you understand the basics of it. So, what is organic chemistry? Now, according to your KLB, organic chemistry, you study the carbon compounds, excluding the oxides of carbon and carbonates. We will study the carbon compounds, excluding the oxides of carbon and carbonates. So we only do the carbon compounds, but not the carbonates or oxides of carbon. No. In organic chemistry, we only deal with the carbon compounds. Now, what you must know about organic chemistry, what we are going to talk about hydrocarbons. What is hydrocarbon? Hydrocarbon is a compound of carbon and hydrogen only. Hydrocarbon is a compound of carbon. So, what is hydrocarbon? Hydrocarbon is a compound of carbon, C, and hydrogen only. And hydrogen is H. So hydrocarbon is made up of only two things: carbon and hydrogen. Right. So that's something that you must understand. Then, after knowing that, you must know the different types of hydrocarbons. Types of hydrocarbons that we have that you must study. We have these types of hydrocarbons. We have alkanes, the first type, the second type, alkenes, the third type of hydrocarbon, alkynes. Alkenes, and alkynes are the three types of hydrocarbons. Alkenes and alkynes. Now today, I want just to do one. Just a bit of one, though I will not finish it. Alkanes. So what's an alkane? Alkane is a hydrocarbon whose carbon atoms are bonded by only single covalent bond. So alkanes are hydrocarbons whose carbon atoms are bonded by only single covalent bonds. So it's hydrocarbons whose carbon atoms, this carbon and this carbon, whose carbon atoms are bonded by only single covalent bond. This is a covalent bond. This one is called covalent bond. Remember in Form 2 work, you learned about covalent bond. You're going to learn it also. So hydrocarbon, that's alkanes. Alkanes are hydrocarbon whose carbon atoms are bonded by a single covalent bond. So we only have one single covalent bond. And so those hydrocarbons that are bonded, or that their carbon atoms are bonded by single covalent bond are called saturated hydrocarbons. Saturated hydrocarbons. Saturated hydrocarbons. Why are they called saturated hydrocarbons? Because they have only single covalent bond in between the two carbon atoms. Between the two carbon atoms, single bond, so they are called saturated hydrocarbons. It is only alkanes that is having this saturated hydrocarbon. If you go to alkenes, you have double bond in between the carbon atoms. If you have to alkynes, triple bond, 3 bonds between the carbon atoms. Now, after knowing the meaning of alkanes, now let's go about source of alkanes. Source. What is the main source of alkane? The main source of alkane, crude oil. You can be asked an exam. The main source of alkane is crude oil. Main source of alkanes, crude oil. That there are other sources: natural gas, biogas, the different sources of alkanes, but the main is crude oil. And in crude oil, remember how you even get petrol, kerosene from where? From the crude oil. So the crude oil is always taken. Then they go the process of fractional distillation. The process of distillation. So we call it fractional distillation, where the crude oil will be processed, and you can get petrol, gasoline, bitumen that we use in roads, and etc. So there we get alkanes also from the crude oil. Now, before I proceed, I want to give an assignment. Go and read about these areas. That one is for you. Homologous series. Read about homologous series and the characteristics of homologous series. Okay? Then read about something called structural formula and molecular formula. The two. What is the difference between structural formula and molecular formula? I'm giving you an assignment before I even reach there. The difference between structural formula and molecular formula. Then read about homologous series and the characteristics. Okay, welcome back. Now, we have done the sources of alkane. Now, after doing the source of alkane, cracking of alkane, you must know. Cracking of alkane. Now, if you want to crack alkane, then if you have alkane, for example, CH3, want to crack alkane. CH3, you are going to see it. Don't worry. CH3, that's now like this is ethane. Remember, it has 2 carbon atoms. Ethane. If you want to crack this one, then you will get maybe methane, CH4, plus ethene plus hydrogen. Now, for this, just know that if you want to crack, like for example, alkane, we are going to see now how these things come to be. Then you can get alkane plus alkene plus hydrogen. If you are like you were given alkane, for example, methane or ethane, then you can get ethene, so plus maybe methane plus hydrogen. Cracking. Now, what I wanted to know in the cracking condition for cracking. If you hear the word condition, is the temperature in this case. What is temperature provided? That's mostly the condition, or even maybe sometimes catalyst. But in this case, condition for cracking here is always in your Kelvin. Condition is 400 degrees Celsius to 700 degrees Celsius, or sometimes it's 600 degrees Celsius to 700 degrees Celsius. That is the condition for cracking. That's the condition for cracking. Around 400 to 700 or 600 to 700. Condition for cracking, degrees Celsius. After knowing that, my friend, know the methods of cracking. First method is thermal cracking. Thermal cracking. Thermal cracking. Thermal cracking. The first method is thermal cracking. Second method catalytic cracking. Thermal cracking and catalytic cracking. So these are two types of cracking of alkanes. What is thermal cracking? Thermal cracking is a method of cracking of alkanes under high temperature. Under high temperature. So cracking of alkanes, it is small chain hydrocarbons under high temperature. So thermal cracking, the word thermal means heat. So thermal cracking uses high temperature. But catalytic cracking use low temperature but under a catalyst, by use of a catalyst. Get the difference? Thermal cracking is cracking of long chain alkanes under high temperature. The word thermal, high temperature. But catalytic cracking is the cracking of long chain alkanes under low temperature by use of a catalyst. From the word catalytic. Catalytic means by use of a catalyst. So that is the difference between thermal cracking and catalytic cracking. Right. Now from there, today is just a bit of introduction. From there, we go to nomenclature. Go to nomenclature. Now nomenclature of alkanes. Talk about alkanes. So nomenclature is naming. In biology, naming. Alright? How do we name alkanes? So nomenclature. Nomenclature. Now, for you to name alkanes, all alkanes end with the word A-N-E. 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 That's how all the names of alkanes end. A-N-E. It's okay. Now, alkanes, the first one is called methane. 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 Methane is the first alkane. A-N-E. Now, this is the name. What is its? So you want to see its name, molecular formula, open structural formula, skeletal formula, and condensed structural formula. Okay. Now methane. This is the name. Now what is its molecular formula? And I told you, go and read about molecular formula meaning and structural formula meaning. Right. So methane is written this way: C H 4. C is carbon. Remember, we talk about hydrocarbon. It has only carbon and hydrogen. Carbon and hydrogen only. Hydrocarbon. And alkane is an example of hydrocarbon. So methane is first example of alkane. CH4. This is molecular formula. molecular formula CH4. Right. Then after knowing the molecular formula CH4, what is the structural formula? Structural formula. Like open, if you can open it. Open structural formula. Now open. Right now, so this molecule. Now see, open structural formula. Carbon. Then hydrogen are how many? 4. Hydrogen are 4. Right? So H is here, the first hydrogen, the second hydrogen, the third hydrogen, the fourth hydrogen. This is open structural formula. Now, carbon and hydrogen, this we said that they are covalent bonds. These are covalent bond. Now, my students, what you must understand and know is that a carbon atom must be surrounded by 4 bonds. Right? Carbon atom must be surrounded by 4 bonds. In form 2, carbon is written this way. Carbon is number 6 in the periodic table. It's number 6 in the periodic table, right? Carbon is always number 6 in the periodic table. Now, being number 6 in the periodic table, what is the configuration? Electron configuration of carbon? 2 to 4. Right? 2 to 4. The first energy level will have 2 electrons. The second energy level will have 4 electrons. So, and this 4 electron is what carbon is using for bonding. Carbon is number 6 in the periodic table, and its arrangement is 2 to 4. 2 plus 4 is 6. Number 6 in the periodic table. And now, this 4, the outer 4, is what carbon is using for bonding. So when it's using this one for bonding, then you must make sure that carbon atom is surrounded by those 4 bonds. So you know where this always 4 is coming from. Carbon must be surrounded by 4 bonds. You are going to see this one in alkenes and alkynes, how it also applies. And that's why in methane is now this open, carbon katikati, then surrounded by these 4 hydrogens. That is methane. Right. Just a bit. Right. So that is a molecular formula and open structure formula for methane. Now, condensed formula, condensed for this one is just the same. The condensed is no problem with this one, is simple CH4, still the same. Now, that is it. For this one, we cannot have skeletal formula, because skeletal formula talks with for carbon. Skeletal formula for this one we cannot get. We are going to see how skeletal formula can be obtained from this. Now, okay, what about ethane? And another example of alkane. Ethane. Ethane is number 2, second alkane example that we know. Ethane has 2 carbon atoms, 2. Methane had 1, but ethane has 2 carbon atoms, 2. So the first and the second. The rest, so this one, then all the rest of the this side, these carbons will be surrounded by now hydrogen. The rest will take hydrogen, will take other parts, this side and this side. It will be for the hydrogen, because we are talking about hydrocarbon, having both carbon and hydrogen only. Now this one is hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen there, hydrogen there. So we have hydrogen here, 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 here. How many hydrogens there? 6 hydrogen. 6 hydrogen. Right? So hydrogen, 6 hydrogen. Look at this carbon, the first carbon. This first carbon is surrounded by how many bonds? 1, 2, 3, 4. 1, 2, 3, 4. What about this one? 1, 2, 3, 4. So a carbon atom must be surrounded by 4 bonds. That's what the core of what I'm telling you. You must know that. Right. So this is alkane. Now, sorry, alkane. Example alkane, which is now ethane. Now this ethane, this is called open structural formula. What about molecular formula? What's about molecular formula? Molecular formula of this one written CH3, CH3. How? Now C, H and how many this side? 1, 2, 3. CH3. Then this one again C carbon. How many hydrogen? 1, 2, 3. CH3. So this is molecular formula. This one molecular formula. This one open structural formula. Of course, we cannot even have condensed formula from this, so it will not be there. So don't worry about that. Okay.